this is going to be my submission for EQ4, which is what is an electrical schematic and how does it relate to the bobots. So here's a general example of electrical schematic. It's a simplification and abstraction of a real circuit. So it'd be a pain to just look at pictures of circuits, so they would rather have a more simplified version of it. Something you can just look at and see symbols, understand what those symbols mean, and be able to relate it to the program. So here's an example of a wire. So a wire is just a straight line. Two wires intersecting, it has a ball, but wires that go over each other are unconnected, which have no ball. So a DC supply voltage symbol is basically the supply of voltage to the circuit, and you have the 5V, the 3.3 volts. So basically just showing you how much voltage is in that part of the circuit. You have ground, which is connection to earth, which is you'll sometimes just see this randomly throughout the circuit, like in here, just connections to the ground. So there's no connection, just means just this wire ends. There is resistors. Resistors, I already went over how they work. They're basically a semiconductor that resists electricity by sending electricity through heat. And this is the 220 ohms, so how much electricity will actually be resisting. So the variable resistor is actually a changeable resistor where you can change how much is actually resisting. And this is, I believe, the maximum of the ohms. Capacitor, nonpolar versus capacitor, or polarized. So basically, does the capacitor have anything in it? And is a polarized, which is basically magnetism. So capacitors hold a temporary electric charge, which are basically like temporary batteries throughout the circuit. The LED light emitting diode uses a diode, yes, to actually emit electricity, mostly through light but not through heat. This is the positive side, this flat part, and this is the negative side. Transistor, a transistor basically have the input and output, so the positive and negative. And based on it, there's electrical current flowing into this wire. This will only go if there's basically electrical connection right here. So normally, if I just put electrical input into this wire right here, it will not flow unless there's also one going to here. Transistors are common and used in binary math. Phototransistor, basically, you need light in order to pass the current through it. It's basically a logic gate. That's what these are. They only allow current passing through under certain conditions. So push buttons, basically push connects the circuit. If it's not being pushed, same with switches, if it's not closed, it's not going to connect the circuit. So example of this is a keyboard, that's a button, series of buttons, and whatever one you push down, it connects a certain integrated circuit, and the integrated circuit can then tell the computer which buttons are being pressed, and it can then send the ASCII code, the ASCII number code, through binary math to the computer to actually process. Infrared receiver, so basically an infrared light will send out a pulse of electricity, and that pulse of electricity will come back, and the infrared receiver can then process this information and see how long it took for the infrared light to come back and how that relates to how far away an object is. If nothing comes back, then it's going to constantly output nothing, and that nothing then says that there's no object in front of it. So the piezo speaker is just a type of speaker. You have the positive and negative, and whenever there's a signal into it, it's going to output a certain sound. The way a speaker works is you basically have a magnet connected to the diaphragm, which is that little movable part of the speaker, and the magnet connected to the bottom of that. And then there's a coil of wire underneath that, and there's a space between the magnet and the coil of wire. And whenever there's a signal flowing through that coil of water, it creates an electromagnetic field, and that pulls or pushes on the battery. And you can then send pulses of electricity to that coil, and it will move the diaphragm up and down. Do that 30,000 times per second. You got yourself a sound. So microcontroller output pin versus microcontroller input pin. So basically, you don't want to have if you want to connect two circuits together, you're not just going to create a giant electrical schematic of the entire device. So basically, in your computer, you're going to have pins, right? You're going to have inputs from different parts of the programs, the different parts of the chips, and different parts of the electrical board. So I might have a pin where I'll have all the electric information coming in from the servo motor, for example, to the computer. Or I might have a pin for all the electrical information coming in from the USB port. And the information can all be processed inside the chip inside the computer that can basically just process all information. And you have the positive and negative input pins. So then you can just see on a circuit, okay, I see a pin, and that pin must be an incoming or outgoing, so like an incoming or outgoing electric current. You have bidirectional pins, which basically can be negative or positive. So this is basically my presentation on the electrical schematic. As you can see, there's many different types to it, and these all combine together to actually form the electrical schematic for the bobots. So based on these, you can actually tell how to, there's actually many electrical schematics throughout the manual, and you can actually read those and tell what they're doing. So this is my presentation, finished.